I'm talking about wind power opportunities and challenges. We have a huge potential of wind power. So just looking at globally how the wind blows, we can draw these kinds of maps that you see here as an example. So basically you need to have about 6 meters per second as an average wind on the hub height of a wind turbine. So here it's 80 meters in this map. So basically you can see that the blue areas are not so good ones, and the red areas are really good ones. But wherever it's yellow orange, it's already good for wind power production. So really we have wind little bit different in different countries, but it is available almost everywhere globally. And why are we talking about wind power and building wind power? So here is an example where they have calculated what does future look like in 2050, when we have much more electricity demand than we have today. How can we cover that electricity demand so that we still keep the climate change or the warming up in the limits of 2 degrees? So these kind of scenarios have been calculated at IEA, and they conclude that by using a lot of nuclear, by using fossil fuel power plants so that the carbon is captured away, we still would need quite a lot of wind power here in light blue, and also solar power here in the orange colors. And then they have also estimated that if we cannot build as much nuclear and carbon capture as they hope in this first scenario, then they have calculated another scenario, a high renewable scenario, that if the nuclear power in yellow is just a little bit higher than it is today, and also the carbon capture it exists but not as much as we could hope for, then we need even more wind and solar to keep the climate change in limits that are manageable for the planet. And then we would need 18% of our global electricity demand from wind power. So this 15 to 18%, how much is it? We have today globally about 3%. So it's like 5 to 6 times more in 2050 than what we have today. Wind power has started to be built in large quantities actually in the 90s only, so it's quite new. And in between 2004 to 2009 it was built huge amounts, in a way when we calculate that every year there was more than 1/3 more added than the year before. So the growth rate for the market was really high during these 5 years. Now it has been a little bit less, but still it's all the time growing. So last year, only in 1 year, they built 50 gigawatts, which means 50,000 megawatts of new wind power plants. And totally we have now 370 gigawatts installed all over the world. And the biggest place still is Europe. Europe is where we started to build wind power in the 90s. Europe was leading for many, many years. Now China is the one that builds most of the new added capacity. And in North America also there is a lot of wind power. And then other places globally are building some, but not as huge quantities as here. We anticipate there are several market studies made how much will be built in future years. This is from a couple of years back in 2013, how they anticipated that there was first this, you can see this is the yearly, how much is built in 1 year, and you can see here in green that there was really high growth during some years, and now it has been still growing, but not as much proportionally. But still they do anticipate that the growth will continue. And also, as we saw from these projections for 2050, how much we actually need wind power to manage the climate change, this is also in line with those projections. Here we also show in blue how much wind power is built offshore. So mostly today the wind power is added on land, but offshore is coming, especially in Europe, because in many countries in Europe there are not so many sites or land available because Europe is pretty crowded in many countries, a lot of people living, a lot of buildings. So in those countries they are looking for building it offshore. So coming to the positive and negative sides of wind power, I'm sure all power production forms have their own list of what are the positive sides and what are the negative sides. And here I have listed in just one slide the drivers and barriers for building wind power. So first is the CO2 emission reduction target, so mitigating climate change. But there are also other positive sides. For example, any power production that is not dependent on fossil fuels will help in mitigating the price changes that we have. For example, when oil and coal and gas prices go up, it has usually a negative impact for the economy. And if we build power production like wind power, where we are not that dependent on fossil fuels, this is also a hedge against these increasing prices. Building wind power means employment, and often in remote areas, because often where you get, first of all, good wind are areas that are more remote, and also when you try to find a suitable place for the land to build wind power, it's often also then you tend to go to remote areas. In addition to CO2 reductions, wind can also contribute to other emission reductions. And also wind doesn't need any water. So in some countries where water is a scarce resource and they would like to use all that is available for agriculture, for example, then wind power is a good choice. Then to the barriers. Why is wind power not built even more? So wind power also has negative environmental impacts. So first of all, they are big structures, so there is a visual impact. This is of course subjective, so some people may even like this, and for some people they don't like them at all, and some people are more neutral about it. But anyway, it is an impact that we do see it in the landscape. Wind power plants, like any structures, mean that birds will collide, and the bird death will then increase when you have a lot of wind power. However, usually because the turbines and the blades and the rotor is rotating, this means that the birds usually a little bit more easily can see the turbines, and not as much birds usually collide to wind turbines than to totally static structures like buildings or electricity lines, for example. Then noise is an issue. it used to be actually quite a lot of issue in the early days, in the 80s, but there has been a lot of research to get the noise levels as down as little as possible. Already we have been quite okay with limiting the noise to only the like 1 kilometer from the turbine. Now in later years we have seen even larger turbines, more than 3 megawatts, and then the noise impact in some cases have become again more of an issue because of the really large structures. So this is a current issue, and a lot of work is done trying to mitigate the possible noise impacts of wind turbines. Noise is one issue impacting the public acceptance. So it is very important for wind power that there is good public acceptance, because building wind power means that you have to build many turbines and many wind farms to get the same amount of energy than from, for example, one big coal or nuclear power plant. So it will be seen more, and it will be more widespread, and also more people are impacted by building of the sites. In some countries also the electricity network cannot handle all the wind power that people would like to build in certain areas. So that can also be a barrier. And then finally, the cost. Wind power is still more expensive than the conventional fossil-fired power plants, for example, even if the costs have come down. The main technology trend over the last decades of wind power is that the size of the turbines have been growing really fast. So in the 90s, we were building turbines that were like 300 kilowatts or 500 kilowatts, or at the end of the 90s started to come the 1000 kilowatts, so the 1 megawatt turbines. And after that it has been going also still to larger and larger. So at the moment they are mostly building 2 to 6 megawatt turbines. The largest turbines at the moment that can be commercially available or you can buy are 7.5 megawatt turbines, and there are 8 megawatt turbines currently in pilot phase. There has still been work and research and development to get to even 10 and more than 10 megawatt turbines. However, it's not sure how big the turbines really need to be, because when you go to 10 megawatt size, also the component size starts to be so large that it will be difficult to move the components along the roads, under the bridges, to the sites. But offshore, of course, you can build even larger turbines, and offshore usually the foundations are very costly, so it is good if you have only a few foundations but really, really big turbines. So I was talking about cost reduction, and that is one of the major things that is happening now in wind power research and development, and has happened over the last decades. Here is one picture illustrating the cost. This is some data and estimations from the US that has a small production subsidy. So this is not the total cost in dollars per megawatt hour. But it's actually pretty close to euros per megawatt hour without this subsidy, looking just as the production cost from wind power plants, or So looking at the investment cost and the operational cost and then dividing to the whole 20 years lifetime. So there used to be quite a lot of difference on the different sides, that if you had a lower wind side of 6 meters per second average winds, and then you had a higher wind side of 8 meters per second average wind speed, the cost was dropping dramatically. It was almost only, it was like half of the cost if you could reach a really good wind resource. But nowadays, the blade development has advanced so much that it's more cost effective to make longer blades. And with longer blades, even in sites that have lower wind speeds, you can capture more energy. And then the cost difference is not so high anymore. And especially the cost reduction that we have seen in the past 10 years has been due to these longer blades, and has especially been stronger for the low wind sides. And this means that the potential for building wind power has become larger. So there are more and more sites where it's cost effective to build wind power. Further cost reductions are still aimed for by improving the design, trying to get the weight down, because weight means materials and costs. Also a little bit the efficiency, the performance can be improved, even if we have already reached quite high numbers there. And then also manufacturing can still be optimized for mass manufacture of the new turbine types. Because so far the development has been so fast, with always increasing size, that a certain turbine type has not been manufactured for very many years. So now we have reached a stage where it is more possible to start really optimizing the manufacture as well. And also the operational phase, how much you put money to maintaining the turbines. That is something that can still be improved, especially when you go offshore or to other remote locations, that you can do preventive maintenance and as much as possible only once a year when you go there. And finally, I would like to talk about the challenge of the energy system and the electricity system. So when a lot of wind power comes to the electricity system, so we will see more and more generation that is variable, and it is also uncertain, because of course we can predict a little bit some hours or even days ahead, but it's not very accurate to predict the wind power production, for example, a day ahead. Also, in some countries we see that wind power potential and the best sites are far from where the major load centers are, and this is a challenge then for the transmission lines to get the power to where it's consumed. In larger shares of wind power, we also see that it comes differently because it's more distributed, and this of course can in some ways be also beneficial, but in some ways it's also a challenge compared to producing in some few centrally located power plants. And then the technology is also a bit different. So it's what we call it's non-synchronous. So it means that when it connects to the network, it will not really automatically support the network. It will follow the network frequency. And this is also something that we are currently doing a lot of research how to get more support from wind power plants to also the second-to-second power system stability. And then one thing is that wind power is not 100% available at all times, even if during those times might be a lot of electricity demand. So the capacity value, how much value there is for the capacity that we add, is not as high as for conventional power plants that can be just dispatched when we want them to start. Of course, the conventional power plants also can fail, so power systems are used to these kind of things, but still there are some new elements coming from wind power. So basically, what is also happening is that wind and solar power are built and they produce a lot of energy, and then there is less room for the other power plants to produce energy, and then they become uneconomical. And this is what is now happening in some countries already in Europe, where some of the gas power plants, for example, are getting uneconomical, and there is the danger that they will be taken out of operation. And still, during some days or some weeks, we would really hope to have them in our power system. So this is one of the challenges also, how to keep the whole power system operational, even with a lot of wind power. We have a lot of experience of wind power, especially in Europe, because we have already several countries, like the pioneering country Denmark. Actually, in 2014, Denmark was producing 39% of its electricity demand from wind power, which is a new record. We also have countries that already produce more than 20% of their electricity, and Europe-wide, we are close to 10% of electricity coming from wind power. So we already know a little bit that it can be managed. You need to forecast, you need to monitor, you need to build transmission, and you need to use also all capabilities of wind turbines to provide also support to the grid. And then you will manage these things. But Europe and many countries are actually targeting even 50% wind, so there is still more challenges coming and work to do in this. And the main solution actually is flexibility. So all parts of the power system need to be more flexible when there is a lot of wind and solar producing. And also wind and solar power plants in future need to be more flexible. So the electricity consumption, the demand can be more flexible, and then all the other power plants can be more flexible, and with this we can manage even higher shares of wind and solar. And then of course we have the future solution of storages, where we can then store when there is excess and surplus electricity, and that can then be used when there is no wind. So a lot of solutions exist, and probably we do need a portfolio of them to manage the system. So this was all for the challenges and opportunities of wind power for today. Thank you.